Welcome to this video on domain and zeros from an equation. We're going to not focus on range for this because range is usually easier done when you have a graph of the function. So we're just going to focus on domain and zeros if you're given an equation. Now domain, just to review, is all possible inputs you can put into a function and get a valid output. Usually we think of it as what x's can we use to get a y value. The zeros are when the function equals 0, and it's when you cross your x-axis, because that's where your function value or your y value is 0. In other cases, they're called roots, factors, if you're talking about certain equations. So zeros is just where your y is 0, so you're on the x-axis. All right, so let's start off with an easy function. Let's do x plus 2 over 3x plus 4. Okay, so we're going to start off with the easiest thing first, which is zeros. So I'm going to set this equal to 0. And then you might be like, well, that doesn't look easy. It actually is. So a fraction can only equal 0 when the numerator or the top number is 0, or the top expression is equal to 0. So in this case, we can ignore the denominator and we can just think about, when is x plus 2 equal to 0? Well, that's an easy equation to solve. Subtract the 2, and the function equals 0 when x is negative 2. So you can write the answer in set notation, which is these braces, I think is the technical term. I call them squiggly brackets. So negative 2 is our 0. So that's, if you have a fraction, just look at the numerator, that'll be your 0. Now for domain, we're going to do kind of the opposite. We're going to look at the denominator. Because if we have a fraction, what's the one thing we can't do? We can't divide by 0. So we have to then figure out what makes it 0, and that's not in our domain. Everything else is. So I am going to erase this. And now we care about the denominator here. So this 3x plus 4 cannot equal 0. So to figure that out, we just have to solve. So x can't equal negative 4/3. All right, so what I'm saying on a number line here, if we're talking the real number system, if this is negative 4/3, I can't be 4/3, but I can be everything below it and everything above it. And I like to write my domain in interval notation. And if you're not totally comfortable with interval notation yet, the main thing to remember is parentheses is like the open circle. It means you're not including the value, and a square parenthesis is you're including the point. So infinity is always a parenthesis because you can't actually get to infinity. But here we don't want to include negative 4/3, so we do parenthesis. And there's our domain. All right, example 2. This time, I'm going to throw in a square root. All right, so we got the square root of x plus 1. So let's again start off with zeros, usually the easier thing to do. I'm going to set that equal to 0. So to get rid of a square root, I have to do the inverse, and that means squaring both sides. And then we just solve for x. So our 0 is negative 1. All right, so now domain, usually the harder part. Whenever I think of domain, I'm always going to start off with my domain is all reals. And then think of things that can break that. So the fraction, divide by 0, that breaks that. Square root, you can't have a square root of a negative number if you're talking about the real number system. So we can't have negatives under here. All that does here is change that our square root needs to be greater than or equal to 0. So we can have a 0 under square root, we just can't have a negative. So all we're doing is really just changing from an equals to saying, hey, it has to be greater than or equal to 0, our square root there. So then you do this out, so it has to be greater than -1. And then interval notation again, so it's greater than or equal to, so we can have a square bracket. And then we go to infinity. Now if you do this and you ever question, do I have my inequality in the right direction? You can test out some numbers. So let's say, what if x were 0? That's greater than -1. So that falls in that domain. So we can do a little check. If x was 0, I'd have 0 plus 1, and that's a valid square root. Square root 1 is 1. And then I could try something less than -1. So let's try -2. So -2 plus 1 equals square root of -1. Now that, while that is actually I, we're talking about real number system here, so that's not in our domain. So we have our inequality going in the correct direction. Okay, now we're going to do 1.5 more questions. All right, so our last-ish example, you'll see why I say ish, is this quadratic. All right, so for the zeros, if we set this equal to 0, we have to do everybody's favorite thing, factoring. So we factor this. And then set each factor equal to 0. And our zeros are 3 and 2. I like to put them in numerical order for my zeros. All right, then for domain, again, we're going to look at things that could break this. We don't have any square roots. We don't have any fractions. Other even roots, like 4th roots, 6th roots, would have the same problem, but we don't have any of those here either. So this domain is all reals, and you can denote that in interval notation by saying -infinity to infinity. Now you can write domain and range in set notation. I just find students make less mistakes with interval notation, especially switching between domain and range, because in set notation you have to then switch from x's to y's. So once students get comfortable in interval notation, I find it's usually less error in that. All right, so that's easy. But what if, here comes the ish. What if instead I just said put an x here? Oh, actually, you know what? Let's put a 2. All right, so instead now we have a fraction. I'm going to leave that factored part there for a second. So zeros, it would be when the numerator equals 0. 2 can never equal 0. So here 2 cannot equal 0. So therefore there are no zeros. Now domain, now we have something in the denominator with a variable, so we can't have that equal to 0. So 0 cannot equal what's in the denominator. So then instead of those being our zeros, now they're where we have a problem in the domain, because if I put in 3, that quadratic would equal 0 and I'd be dividing by 0. If I put in a 2, that also would be 0. So like if I did 2 squared minus 5 times 2 plus 6, I get 2 over 4 minus 10 plus 6, which is 2 over 0. So you can see I would be dividing by 0. So those are out of my domain. But any other number, I might get crazy numbers, but I would still have a valid number in the denominator. Now writing the domain can be a little confusing for this, and a number line can help you not miss part of it. So this is the only place where interval notation is a little clunky, but I find the number line helps out a lot. So essentially, I don't want those two numbers I want everything to the left, in between, and to the right. All right. So I'm going to start with negative infinity and go up to 2, not including 2. And then I'm going to go from 2 to 3, again, not including either endpoint. And then I'm going to go to 3, from 3 to infinity. So it's this middle part that's sometimes forgotten, but remember, I could put in like 2.5, and it wouldn't be fun math to do, but I would get a number. So sometimes this number line can help. All right, so there's the basics for finding domain and zeros from an equation. I hope this helped, and I'll see you in the next video.